Technically, according to the book, there is some new material in this, but I have been preparing you for these moments before. So I'm going to put the examples up, and it's a perfect opportunity to have a chance to go through this again together, because trig, anytime it's a trig day, very important. So you have a chance to learn from me again. But there are some things that I believe, according to the book has not given you angles higher than 360. That's what it seems like, because one of the titles is angles greater than 360. But we know what to do with that. I've been preparing you for that all along, because it's not difficult and we're doing the same thing. So we're going to jump in here and take a look at what's going on. We are evaluating without a calculator. That is the instruction of all of these today, so I'm not going to write that every single time. But we were even reviewing this on the worksheet the other day. And this example doesn't even have an angle higher than 360. So it's very much a review day. And so I think we can zip through this and give you some good homework time today. How should I begin every trig problem? With a graph. Okay. So let's get that going for each of our angles here. So here we go. Let's get the flow going. You notice how I do the same thing over and over so that you can do the same thing in your head. What quadrant is 135 in? Second quadrant. What is the reference angle? 45. Thank you. Draw the triangle to the x-axis. And what are the ratios? 1, 1, radical 2. And don't forget, I do the same flow every time to help you remember. Now, can you give me the cosine, please? Close. Did I hear the opener? Negative radical 2 over 2. Very good. This isn't our first time, so I'm not breaking it apart anymore. I'm just asking you to note the negative or not. All right, now let's go to the second. 330 is in which quadrant? Fourth quadrant. With what reference angle? 30 is correct. Draw the triangle to where? X-axis. Okay, now across from 30, I write what? 1. Across from 60, hypotenuse. And don't forget. Good. Okay, pause for a second, let you catch up so we're not losing everybody. Okay, now what we're looking for is the tangent. So what do you have to say? Thank you for the negative. We learned. Negative radical 3 over 3 is correct. Very good. Now we are not done. What do we have to get? Common denominator of 6. Thank you for that. What does the first term turn into? Negative 3 radical 2. Okay, then what do I write? Minus, thank you. 2 radical 3 is correct. Can I combine any further? No. They are not like terms. Okay, how many do we have of these? We have 3. Let's do one more together and then have you try the third, and you'll see just how quickly we can go through this. I hope that we are catching on. I hope that when you see these types of problems on your last test of the quarter, that you will be confident on them. Couple of cosines this time. That's okay. We got different angles, so it'll make different answers. Let's start with the negative 60. What quadrant is negative 60 in? Fourth quadrant. With what reference angle? 60, because that's how much we have gone down. Negative tells us to go down. Draw the triangle to the x-axis, always. And answer this. Where does the 1 go? On the top part, adjacent to the 60. I'll take it. Across from the 60, I write hypotenuse. And don't forget. Okay. Okay. Do we have an answer for the cosine? It is 1/2. And it's problems like this that you'd get lucky if you forgot all students take calculus, because it's going to be positive anyway. So there you go. All right, let's go to 210. What quadrant are we in? Third quadrant. Get that going here. What reference angle? 30 is correct. Draw the triangle to the x-axis. What do I write across from 30? 1 across from 60. Radical 3, hypotenuse. And don't forget. Very good. Okay, pause, let you catch up a little bit. You are getting good at this. I like it. You sound intelligent. You sound like you're learning, and I love it. Okay, you're doing a great job with these. Do we have an answer for the cosine of that one? I hear negative radical 3 over 2 is correct. Adjacent over the hypotenuse, and we are in the tangent quadrant, which makes it negative. Excellent. Now, what do we have going for us here? We have the common denominator. So we don't have to make any changes to our numerators. Can I go any further? No. Do we feel ready to try 3 on your own? I like it. I like the confidence. Give me a second to finish that up if you're still copying. I will tell you this. If you have your calculator nearby, you might, if you need a simple calculation, these angles are higher than 360. So we haven't run into that yet, but you will in this example. But you do know how to handle that. So I feel confident to let you try that. Are we ready? All right, here we go. Same instructions. Evaluate without the calculator. So again, if you need the calculator to tell you what 570 minus 360 is, then that's okay. That much calculation is okay. But the rest of your answer must be supported with non-calculator work. After you copy it down, go ahead and begin.
Yes, it is 210. You want to take you by the end of it? No, 570. 570 goes around. It goes around and then goes around. It goes 21 there. It's 570. 21. 30, buddy. 21 0. It's 30, buddy. Get 21 0. 6.
I hope you're beating me and getting this done ahead of me. I hope we feel confident on this. I know that this is lesson 36 and the test is up to lesson 34, but I'm telling you this is review. Like we've done this before, right? So this is test material. So these are built on previous lessons. So this you could definitely have problems like this showing up on that test, which is next Friday. So I hope that we're feeling confident on this stuff. And don't give up on this. Like you have not reached the end. This is not the end of trig. We have a lot more to build, but you are in good shape. We are laying a solid foundation to be able to grow on this even more. I reminded Seb was making 540 comments, and I was reminded. Do you know about math in? And this doesn't really. I mean, you might talk about it in geometry, but it doesn't really happen until you get to trig. Skateboarding, I know, is a field that does this. I think like maybe in like some rollerblading, kind of X Games sort of things, maybe BMX kind of stuff. Have you heard the terminology of doing a 360 or doing a 180? And so, what is a 540? One and a half, exactly. So these are real life terminologies that people use, and it has mathematical foundations. And this is the kind of stuff that you're learning and you're understanding. A 360 is a full spin. Oh, by the way, here's another one of my favorite things that people do wrong. Have you ever heard of someone like they're really trying to get their life together, and so they're really they're going to do better, and so they're going to make a real 360 in life? Have you ever heard of somebody saying that? Why are they wrong? Because they're walking the same way. What do they mean to say a 180? Right. So I don't know if you've ever heard somebody say that wrong, but that's another mathematical thing. So just bringing that up is to pertains to what we're doing and how people talk about it in real life too. Stop that.